Hello? Oh, okay. So, welcome back to Random Mania with Sir Shark here. Last time I talked about calculus and Mr. Beast. This time we'll be teaching about chemistry and Livvy Dunne. Now, if you don't know who Livvy Dunne is, this is her. She's kind of like I don't know if she's popular because she's some kind of stupid thing. And yeah, okay, so that was clickbait. So I'll just go to chemistry now. And specifically, we're going to look at organic chemistry. Now, what is organic chemistry? Well, organic refers to carbon, and here is carbon. Oh, wait, yeah. Oh, you can see carbon, right? C. C means carbon. If you don't know what C means, then I am saying this. Okay. Let's see. Let's get a whiteboard up. Yeah. So organic chemistry is very important in high school, of course. Even if you're not in high school, it's always useful to know like some cool science tricks you can pull out on your friends, or like you can just say a bunch of nonsense to someone you meet randomly, and I don't know, you might get some satisfaction from that. Okay, carbon. Element 6. It has two valence shells, or two electron shells, which means there's one electron here, and then another shell containing another set of electrons, one here, one here, one here, one here. It's very, very messy, I know. But this is carbon. There's also 6 protons and 6 neutrons, normally. Now, there's also different types of carbon, which we'll get to later. But in organic chemistry, you just have to focus on this kind of carbon, which is called carbon 12. It's called 12 because 6 protons plus 6 neutrons is equal to 12 particles. We're ignoring the electrons, by the way. So in carbon 12, right, 12 protons and 12 neutrons, why is this so important? Why is this such a basis for an entire module of chemistry? Well, you may or may not know this, but our body is composed of a lot of carbon. Like all of our DNA, all of our, like everything is made of carbon. Because it's a building block of all kinds of life. It's in our DNA, it's in our RNA, which, if you don't know, is like DNA, but like for different organisms, and like a single strand instead of double helix, like we all know. Carbon is used for transmission of other chemicals like water, to get water and like to use it as something useful for your body. You need carbon. And even sugar, like sugar is C11H22O11, which has carbon, right? And same thing with glucose, which is C6H12O6, which you probably have seen this formula before if you've done photosynthesis and cellular respiration. So yeah, as you can tell, carbon is a very important thing in chemistry and biology and like in general, right? Because it's just a very important element. Now, I know what you may be wondering, why is carbon important exactly? Like, what properties make it so important? Well, first of all, if you look at this shell right here, it has 4 electrons on the outside. Now, so this is a second shell, it needs 8 electrons to complete a full shell. So either it can gain 4 electrons to get a full shell, or it can lose 4 electrons to get, a complete shell as well. They both are stable. But depends on the context, but usually it's going to be plus 4. No, not plus 4, minus 4, because you want to share electrons. Carbon is usually used for covalent bonding. Like, for example, C and H, this is considered a covalent bond. C is carbon, H is hydrogen. This dash means they both share 1 electron each from each of their shells. And yeah, so this bond CH is going to be very important. And if you don't know what a covalent bond is, basically they share electrons on the outside shell. This outside shell, on the outside, of course, is called a valence electron shell. And this is going to be very important because if you want to understand why carbon is so important, you need to look at the number of different bonds it can make, which is 4, because maximum of 4, because it has plus 4 or minus 4, because of its outside shell, which is pretty unique for an element. Like, I mean, silicon has like +4, I think. I don't actually remember how many. Wait, silicon. Let's see. Yeah, 4 electrons. So both carbon and silicon have 4 electrons. So technically, this is also why silicon is also a very important element, but not for the same reason as carbon. So yeah, the basic building block of organic chemistry is CH bond, which, because all organic compounds are made of carbon, and most common type of carbon bond is with hydrogen, of course. Now another common type of carbon bond is with oxygen. Now usually it's like C double bonded to O, which means they both share 2 electrons from each, so 4 electrons in total, right? This is called a double bond. And there's also something called triple bond, like this. For example, nitrogen has triple bonds since it's missing 3 electrons, so it wants 3 electrons back from the carbon to complete its own valence shell. But we don't care about nitrogen for now. So far, just carbon and hydrogen, and carbon and oxygen. So, for example, in carbon dioxide, right? OCO, 2 double bonds, and this completes both oxygens and the carbon, since it has the 4 bonds it needs to complete it. What's it called? Valence shell. Yeah. Elements want to complete stability by getting all the valence electrons. Yeah. Now the reason why carbon dioxide isn't actually considered an organic compound is because it doesn't have any hydrogen in it. I'm pretty sure that's why it's not. Yeah, I'm pretty sure it doesn't have any hydrogen. So yeah, OCO looks like organic compound, has carbon, has oxygen, but no. Okay, let's get onto a proper organic compound. For example, CCH. Okay, I'm just gonna draw it first. Hopefully my handwriting is not that bad. So as you can see here, hydrogen only can bond to one element at a time, because it only has 1 electron it needs to complete its shell. So as you can see, each hydrogen occupies one different thing. That's not great wording. Yeah, one different element. We're all bonded to a carbon. Now this carbon here has 4 bonds: 1 hydrogen, 1 hydrogen, 1 hydrogen, 1 carbon. And this carbon here has 4 bonds: 1 carbon, 1 carbon, 1 carbon, 1 hydrogen, 1 hydrogen, 1 hydrogen. That's 4 bonds to that as well. Okay, so as you can see here, this molecule is stable because everything is complete. And okay, what's this called though? And this is called ethane. Oh, jeez. What? Okay, ethane. ETHENE. Now, you might have heard this before, or you've had something similar called ethanol. Now, I'll get to ethanol later, but just a hint, it's basically ethane with an oxygen, which is what this all means. Like alcohol refers to the presence of oxygen in it. Okay, but why is this called ethane, and what does this mean? Is it like a family or something? And spoiler alert, there is. Okay, ETH refers to two things, which in this case means 2 carbons, right? Carbons. And ane refers to the fact that these are all single bonds. Now there could also be double bonds, not between the hydrogens actually, between the carbons. So the carbons here are only single bonded. However, if they were, say, double bonded, which is possible, it's called ethene, and it looks like this. Everything's complete here, and ethine, which is one bond here, triple bond here, 1 bond here. Yeah, that's ethine. Yeah, so those are the basic types, but we can go on from here. So eth means 2 carbons, but we can also have 3 carbons, right? This is called, stupid. It's called propine. Oh, yeah, let's just stick to here. This is easier. Propane. Yeah, you probably had propane before, propane gas, like barbecues and stuff. So prop means 3. I believe it's from Greek. I'm not sure. Yeah, prop means 3. And this is represented by CCC, H, 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 H. yeah, that's it. Everything's complete here. So it's called propane, and this pattern continues indefinitely. So you can have like just a bunch of carbons, right? And hydrogen. Each of them has 2 hydrogens, except for the end points, which have 3 hydrogens. So, for example, if there's like n carbons in here, right? It's like Cn. There's also two n hydrogens plus 2 on either end, so it's CnH2n plus 2. And this is called, okay, well, it's no proper name because it's no prefix, but N with the prefix for N, right? For example, if this is like 8, it's called octane. And this would have 8 carbons and 18 hydrogens. Cool. So why is this important? Well, these chemicals are used as fuels. Sorry. You probably heard of propane before, right? As a gas, as a fuel. You can burn propane. This formula is C3H8, by the way. And to do this, we need the combustion formula, which is basically C3H8 plus some amount of oxygens, right? And this was supposed to give H2O plus CO2. Now, keep in mind this is complete combustion. Incomplete combustion means not enough oxygen. And by the way, I haven't even gone into chemical reactions. So just pretend this is like addition. So each element is kept the same on either end. For example, we have 3 carbons here, so you want 3 carbons on this side as well. Okay. Okay, well that's actually pretty easy to do, except it's not, because there's going to be an imbalance of hydrogens. So we need to figure something out. First of all, there's 3 carbons here, so it's a good idea to put 3 carbons here as well to balance out the carbons on either side. So that gives 6 oxygens so far, okay. And then 8 hydrogens, so there's more hydrogens than carbons, so this prioritize the hydrogens. So it should be 4 H2O, because 4 times 2 is 8. Okay, so we have 4 plus 6 is 10. 10 divided by 2 is 5. So this is a balanced equation. This is combustion of propane. Now you can have similar equations for other hydrocarbons. You just need to do this like algebraic like mishmash of everything. And that's how you find the combustion reaction for propane, which is the main reason why these fuels are useful. But they're also used in other things, like for example, ethanol. You get that from ethane directly, and that's used in like alcohol, right? So there's definitely other applications. And you can make more complicated compounds, like as I said before, sugar and glucose. Those are made from individual like substituents, right? Oh yeah, I forgot to mention, ethane is actually the first thing with carbon. It's actually methane, which is CH. You probably heard of methane before. It's like the thing that cows make when they fart. Yeah, 1 carbon surrounded by hydrogens. This carbon has all there is, right? It's a sigma. Which is what you guys should be as well. Like I hope, like once you guys have done your tests, like I don't know where you guys are watching this anyways, if anyone even watches this, but once you're done watching this, make sure to post some women or men or I don't know, something. Yeah, so methane only exists for a single bond because obviously there's actually no actual bond here because it's just 1 carbon. There's no carbons bonded to each other. And going to ethine and ethene. So similar pattern here, except that instead of just like doing a bunch of double bonds like this, like that's not how it works. It's supposed to do like one double bond and then do like boom, 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 and then you stretch it out, and then there's like 1 here above these 2 double bonded ones, and then everything else is like 2 on either end, right? No, 1 on either end. That's what I meant to say. And yeah, and then ethine is pretty similar, except instead of having just 1 pair, we have 0 pairs on the triple bonded carbons. So just skip those entirely. We already have enough bonds, right? For example, this is a type of ine, not an ethine, but like ine. Here's prefix table. So meth is 1. That's only for methane, so it doesn't really matter. Eth is 2. Prop is 3. Bute is 4. I'm sure it's called bute, but I don't know. And then pent is 5. Hex is 6. Sept is 7. Oh, actually, it's called hept because heptagon, right? And it makes more sense heptane rather than septane because that just sounds worse. An oct 8, non 9, and dec 10. That's basically all you need to know for now. Yeah, so we can apply this to these different ein, and ein. Now, what's important to notice here is that once you go up from ethine, or ethane, or ethene, or ethine, or whatever, because there's a double bond or a triple bond or like whatever, and it's not a single bond, you may notice they can just like replace a triple bond like here or something. Like, what difference does that make? You may think. Well, actually, there is a difference because the properties of the molecule are actually based on symmetry. And since this is different symmetry to this, like they're completely different molecules. So what is this called, right? Okay. This is wait, what? And this is butine. And we have a triple bond in the first carbon, between the first carbon and the second carbon. And we can say like 1, for example. More formally, actually, but 1 ein. You put the 1 between the but and the ein, the prefix and the ending. And we can also do it like the triple bond here, and that's called but 2 ein, because between the second and third carbons. So we give a numbering so we can specify the exact type of molecule you want. And notice if you put the triple bond here, it's actually no different from but 1 ein because of symmetry. You can just flip the entire thing around and it looks the exact same. So it's just but 1 ein and but 2 ein, right? Now, what are these chemical differences and properties? Well, we'll find out later. Wait, where's my thing? Okay, so now let's go on a bit of a tangent. Yeah, so actually I don't want to talk about Livvy Dunne anyways. I want to talk about the Tuah. The NFTs, whatever, financial loss. Yeah, so basically she made a coin, NFT, whatever, Tuah coin, that basically plummeted in value by $440 million in like 20 minutes. Why do I keep up with this stuff? I don't know. I just suggested and I watched like 3 videos. I know she came popular anyways, just like Livvy Dunne, just kind of stupid. Yeah, okay. I guess I end the video here because why not? This will be a funny thumbnail. Wait. I don't know. Okay. Bye.